All right, so yesterday we first started talking about a derivative, and we used that big, long definition of the derivative. Well, there's a shortcut. Now, the shortcut doesn't work in every scenario, but for the ones that you're going to be doing, it'll work in every scenario. So it's called the power rule, and the power rule says if you have a function a times x to the n power, so a is going to be representative of a number, n is going to be representative of a number, and that's what that says down here. They're going to be real numbers. Then the derivative of f of x is equal to n times a times x to the n minus 1 power. So essentially what's happening is that n is going to come down here and multiply times the a, and then you're going to decrease that n by 1. So first example here, pretty simple, x to the 12th power. So there is no a value there in front. We'll deal with one that has one here in a minute. But that 12 is going to come down and multiply times the 1 that's actually really there. So the derivative is equal to 12. 12 times 1 is 12. X, bring the power down 1. That's your answer. So you could go through that big process from yesterday. Now, of course, I don't want to take any x plus h's to the 12th powers. But if I did that and I simplified, everything would cancel out to give me just that. Now, the next three will also work that way, but we have to make them in that form, a times x to the n power. So for b, I need to think of that as being x to the negative 3 power. If you remember from Algebra 2 and from Pre-Cal, that negative exponents normally put you on the bottom of a fraction. So being that I'm in the bottom of a fraction, if I make it negative, that'll put me kind of back on top. So now if I do the derivative of that, okay, so I'm going to multiply this negative 3 in the front, and then bring the power down. Now, when I bring the power down, I'm going down from negative 3. So that's actually going to be negative 4. Because if I went to negative 2, that's actually getting higher. Now, notice here, final answer should be simplified as much as possible, only contain positive exponents. We don't really write negative exponents. I can't really give you a reason why, but we don't. So I need to put that back in the bottom of a fraction. So that's going to be f prime of x is equal to negative 3 over x to the 4th power. And once I move that to the bottom of the fraction, now it's positive. Now c, again, right now I can't do that. I need to write it as x to some power. Well, a square root is the same thing as a 1/2 power. So I multiply that down in front. Bring the power down 1. Now, when I bring the power down 1, I'm subtracting 1. So 1/2 minus 1 would give me a negative 1/2. Now, you can leave the fraction exponent, but I can't leave the negative. So I'm going to write my answer one of two ways. Put that negative 1/2 in the bottom of a fraction. So that's going to be down here with that 2. So I can write it like this. Okay? And the 2 here is that 2 right there. Or, if you don't want to write a 1/2 power, 1, 2 square root of x, because that's what a 1/2 power is. Either one of those would be acceptable. Okay. All right, now the last one's kind of a combination of b and c. I have a cube root of x in the bottom of a fraction. So a cube root is the same as a 1/3 power. But since it's in the bottom of a fraction, I need to make it negative. Let me rewrite that because it kind of all ran together. Okay. So now, multiply that down in front. Negative 1/3. Okay. Now, when I subtract 1 from that, it's going to get even more negative. When I subtract 1, I'm really subtracting 3 over 3. So negative 4/3. Now, it's okay to have a negative number. So the negative 1/3 is okay, but the negative 4/3 is not because that's an exponent. So that's going to be negative 1 over 3 x to the 4/3. Okay, and that's perfectly fine. Or negative 1, 3, and I'm going to switch colors here so this is obvious. The cube root of x to the 4th power. And that came from this over here. Okay, a fraction, the denominator is your root, the numerator is your power. So 3 on the bottom is a cube root, 4 on the top is a power. You can write your answer either way. Just be flexible. I don't remember how your book writes their answers, so if they write it one way and you write it the other, they're both perfectly fine. Now, what we did here is we did derivatives. That process is called differentiation. So if you see a direction that says differentiate something, you might see it say differentiate y as opposed to x. I'm forgetting the exact wording, with respect. Differentiate y with respect to x. That's exactly what we've been doing. Okay. So a couple more rules we'll throw in here, and then we'll do some other examples. So think about a constant. Okay, so you know that the derivative is the slope of a function. So if you have y equals c, where c is some constant, so that would be something like, let's say that right there is c, okay? It'd be a horizontal line. The slope of a horizontal line is 0, which means the derivative of that function would have to be 0. So if you're taking the derivative of a constant, that's just going to be 0. And then derivative of a sum, this is in your formula booklet, but I don't think you probably really need it. Essentially what it says is if you have two things added together, at least again for our purposes, any two things added together, you can take the derivative of each piece and then add them together. So this, we've got f of x, we've got g of x. Notice those are in our proper form. If we want to do the derivative of those two things added together, I just take the derivative of them and add them together. That's it. Now, this does say derivative of a sum, but it also works for subtraction exactly the same way. Okay. So, A here, pretty straightforward. Take the derivative. So f, hold on here, f prime of x. Okay. Now, that 3 is going to come down in front, and it's going to multiply times the 4 that's already there. Now, you can write 3 times 4 if you want to, but I'm going to eventually want you to write 12. So whatever you want to do, bring the power down, okay? Bring that 2 in front, multiply it times the 2 that's already there. Bring the power down. You can write 1 if you want to, but there's no reason to. And then at the end, 0. That's the derivative of 3. Now, there's no reason to write that, but I just wanted to make sure you knew why I don't have the 3 in the next step. Okay, that's my answer. I don't need to see any work for that. That's something that once you get the hang of it, you should be able to do pretty quickly and pretty easily, I think. Okay. All right, next one's got some fractions in it, so that's going to make it a little bit harder. But for the first one there, when I bring that 3 down, I multiply it times the 1/4. That's just going to give me 3/4. Bring the power down. When I take 3/2 times 2, the 2's will cancel out. You can do that directly, or you can think of it as being 2 times 3/2, which is 6/2, which is 3. So whatever way you go about it, just remember that that's only going to happen when the denominator is the denominator, the bottom number, is the same as the number you're multiplying by. And sorry, here I should bring my power down. And then at the end there, when I take the derivative of that, so there's a 1 for my power on the x. 1 times 1/3 is 1/3. Bring the power down. Now I have no more x's. So anytime you take the derivative of just x to the first power, you're always going to end up getting rid of your x's. Okay, so that would be my final answer. Okay. And last one here, f of x. I need to think of this actually as 3x to the 1/5 power plus 8. Now it's in that proper form. So I'm going to multiply the 3 times 1/5, so that's going to be 3/5 x. Bring the power down, so subtract 1. And then the 8 will just be 0. Again, you don't have to write that step. Rewrite this because I'm not allowed to have a negative exponent. So 3/5, put the 4/5 down there. Okay, or again, if you would rather, 3, 5, 5x, 5th root of x to the 4th. Okay. Either one, again, of those would be acceptable. Now, this is a little hard to see here. This is a 5, not a 6. Okay. Now, just kind of like the last one there, if your problem is not in polynomial form, where it's just a bunch of x's to powers that could be fractions, not be fractions, whatever, you need to make it in that form. So for D, I can't do the derivative like that. So I need to multiply that out first. So that's going to be the same thing as x squared plus 4x minus 2x minus 8, which would be x squared plus 2x minus 8. Now that I can do a derivative of. So f prime of x would be 2x plus 2. Again, I don't need to put the 0 in there because we would just get rid of that anyways. Okay. Last one of these, divide everything by x. Now this one's a little bit weird because when I do that, I can't divide 3 by x, but you have to divide everything. So I can't just divide the first two and then not the last one, but I can't do a derivative in a fraction like that. So 4x squared plus 2x minus 3x to the negative 1 power. Okay, remember you can turn fractions into negative exponents to do your derivatives. So 8x plus 2 plus 3x to the bring your power down. Not allowed to have a negative exponent though. So 8x plus 2 plus 3 over x squared. Now, to be honest with you, I'm not really sure what order you're supposed to write that in. You know that, like, over here for this, for example, that you don't write that as 2x minus 8 plus x squared. You put the x squared first. In this case, though, since that's an x to the negative 2 power, I don't know if you put it at the end or put it in the middle. Just be flexible. There's not, in my opinion, a wrong way to write your answer as long as you've got all those terms correct. But if your answer doesn't match what's in the book, you can ask me about it, but I'm sure it's fine, just written in a different order. All right, so just a couple more things here. A derivative you can symbolize as f prime of x, as y prime, or as dy over dx. That's the more of the differentiate y with respect to x. We're pretty much just dealing with x's and y's, but you could have different letters. And in more complicated calculus, and this is even more complicated than the Math SL class does, you can have more than one letter in an equation, like on the right-hand side, and just ignore one letter and just focus on the other. But we're not getting into that. Okay. All right. So a definition of a second derivative is the derivative of the derivative. So you can symbolize that as f double prime, y double prime, or d squared of y over d squared of x. There are higher derivatives. You can do a third derivative, a fourth derivative, whatever, but we're only going to be doing first and second. And if I remember reading correctly on the exam, you wouldn't have to do anything past a first derivative. But I'll double check on that. So in this case, what we're doing is we're doing a derivative, and then we're going to plug a number into the derivative. So for a, f prime of x, okay, here's my f prime. We're good to go. Everything's set up correctly for that. So f prime of x is equal to, okay, so negative 4, bring that down, multiply it times a negative 3. So 12x, bring your power down, so we get more negative, plus 2, because the x will go away. Now, again, not allowed to write that. So 12x to the positive 5th power plus 2. Okay. Now, for the next step, I actually want to plug negative 2 into that. So 12 over negative 2 to the 5th power plus 2. And really, you can just type that in your calculator just the way it looks. But if we do kind of some baby steps here, that's going to be 12 over negative 32 plus 2. That's going to give me 1.625. Okay, and that's it. Now, second derivative, I'm going to do the derivative of the one up above. So derivative of f of x. Sorry, there's kind of a f prime of x, sorry. There's a little bit of a lag going on here. Sorry about that. Okay, so I'm going to do it in that form because if I do it in my final form there where it's written as a fraction, I'm just going to have to write it with the negative exponents anyways. So I'm going to go ahead and write this down here just so I don't have to look up so far. Okay, so this is what I'm going to do the derivative of. Okay, so f double prime of x is equal to negative 60 x to the, bring it down one more. Now this time the plus 2 goes away, and again, you don't have to write that step. Rewrite it not as a negative exponent. So that's going to be negative 60 over x to the 6th power. Okay. Now for my part D, plug in negative 2 again. There's not really a reason that both of these are negative 2. I don't know if you've got ones in the book where they're the same, but it could have been any number. That's going to be negative 60 over positive 64. Remember to be careful when you put negatives in your calculator to powers. Make sure you put them in a parenthesis, so it is a positive 64, not a negative. And that's going to give me negative 0.9375. All right, now we're going to do a little bit of an application question, and then we'll be done. Okay, the height in feet of an arrow after t seconds can be modeled using the formula S of t is equal to negative 16t squared minus 64t plus 512. So we're using some different variables here. T is like x, and then S of t is like f of x. So find the initial height of the arrow, then find the height after 2 seconds. Okay, so this equation, it says in the example, models the height of an arrow after so many seconds. So find the initial height of the arrow. That initial height is going to happen at t equals 0 seconds. Because initial would be at the beginning, and the beginning is going to be at 0 seconds. So that's going to be now then negative 16 0 squared minus 64 times 0 plus 512. And that's probably something you should be able to look at and just tell, hey, that's going to be 512 feet. Okay, now what is the height after 2 seconds? Same thing, that's going to be t is equal to 2, or S of t. Sorry, S of 2 is what I meant to write. So negative 16, 2 squared, minus 64 times 2, plus 512. And that would be a good thing to write down just in case something goes wrong in your calculator. At least show that you are plugging in 2. That way that they can give you some partial credit for your answer there. Now, that shouldn't seem unusual that it's going down. If you shoot an arrow, it does have to eventually go down. So in this process, we're already on the way down. Next one, how long does it take for the arrow to hit the ground? Okay, so when you hit the ground, your height is going to be 0. So actually, in this case, we want to let S of t equal 0. So negative 16 t squared, 64t, 512 is equal to 0. And then solve that. Now you could use the quadratic formula, but for the most part, I think they're not going to really expect you to do that. So you could graph it, but this would not be a really easy one to graph. I can actually factor out a negative 16. Now I forgot you've got that equation solver, so you could use that too. I guess it just depends on the directions. If it doesn't say that you can't, then go for it. But in this case, we can continue factoring here. Remember, I'm looking for two numbers that multiply to give me a negative 32, but I had to give me a 4. I end up with t is negative 8, and t is 4. Now, negative 8 doesn't make any sense. You can't have a negative amount of seconds for an arrow to hit the ground, so it's going to take 4 seconds to hit the ground. Now, why do you get a negative answer? Well, your arrow is starting at a peak. I'm starting at 512 feet. So if you go backwards in time, which again doesn't make any sense, that's where you're going to see it be at 0 on the left of the, say, y-axis. But again, that doesn't make any sense. So, all right, almost done here. Find s prime of t, the derivative of s of t. Now, this represents the velocity. So this is something we don't really talk about too much in here. But the first derivative of what they call displacement, which is where you are at any given time, which is that S equation, the first derivative of that is called your velocity equation. So that's going to allow me to find the speed at any given time. So my velocity function, here is the function that tells me the height at any given time. Take the derivative of that. So s prime of t is equal to negative 32t minus 64. Okay, now find the speed when it hits the ground. Well, it hits the ground in 4 seconds, so find the speed at 4 seconds. So s prime of 4 is negative 32 times 4 minus 64, and that's going to give me negative 192 feet per second. Okay, so velocity is always going to be in some unit of length over a length of time. So in this case, we were doing it in seconds, and we're doing it in feet, so feet per second. Now, the fact that it's negative might seem weird, but velocity is what we call a vector, and it has direction to it. So in this case, the negative 192 just means that it's traveling down as opposed to traveling up. All right, last part here, find s double prime. Now, s double prime represents the acceleration. So the first derivative is the velocity. The second derivative is the acceleration, which means how quickly it's changing speed. For the most part, acceleration is kind of tricky to explain. So, of course, I know that my first derivative was negative 32t minus 64. So the derivative of that would be negative 32. And the units for that are feet per second squared. Now, I can't really give you a good explanation as to why that is, but that's the typical unit there for acceleration. Okay. All right, so most of this homework should go pretty quickly. Again, as always, if you've got questions, let me know. We will have a quiz over the material after section 12.3. So that'll be, we'll finish that up on Monday. Tuesday, you will be working on your paper, and then we'll do a little bit of, have an opportunity to ask questions, maybe not a formal review, but then we'll have a quiz over sections 1 to 3 on Thursday.